Alright guys, welcome back. So, today we are going to be creating player movement. I know, I've been prophesizing it for 2 episodes now. It's long overdue. We want to get our boy, little Mr. breathes at the same rate my dog does after he goes for a 10-kilometer run. We want to get him moving left and right. I've experimented with a couple of different ways of doing this, but we're going to go with the most basic. Now, what are we going to do? We're going to create a script called player movement. You could, if you want to, just call this player and put the jump component in this, but I understand that some people don't actually want movement, so left to right movement. They don't want that necessarily. Also, the jump portion might not work with their game. Anyway, the point is, you can just call this player if you want to, but this will be player movement for me, and we're going to be doing movement and jumping in a different script from one another. And we'll be accessing those, so. Player movement. Press enter. We're going to open this up in Visual Studio. And if you get this dialog, the project assembly -C# has been modified outside the environment. That means that you made a change in Unity. So, as in a change in Unity that was not made within Visual Studio, and it just needs to reload so that it can tell what has actually happened. So you just click reload all. To begin with, we need to explain what we are trying to do. We want to give our player object some physics so that he can move left and so that he can move right. Now, currently, he doesn't have any components on him that can make him do this. He's not going to respond to gravity. There's nothing on him telling him to fall. Right now, we're actually not going to focus on falling. We'll get to that when it comes time to make him jump. That will be a grand episode in itself. But right now, we just need to perform the measly task of making him move left and right. So what we're going to do is we're going to add a new component to him. Actually, we're going to add 3 new components. So we're going to click Add Component. We're going to look for what's called a rigid body 2D. Because we're in the 2-dimensional plane, not the 3-dimensional plane. We're going to add that to him. And right now, we are going to change this gravity scale to 0. Now, a rigid body is an object that makes your character respond to physics. That's really all you need to know. It's got a bunch of different options that you can change. So it's got this dynamic. You can change it to static, which we did before, you might remember, with the platforms. So we've looked at rigid bodies slightly before, but never in this depth. Currently, our player has mass. He'll have drag, angular drag. We're not going to go into any of the maths surrounding that kind of thing. Collision detection, sleeping mode, interpolate, yada, yada, yada. One thing we are going to look at is we're going to look at his constraints. I have never in a platformer, other than Sonic the Hedgehog, seen a character spin around. And technically, there is no point in that game where Sonic will go from running, jump off a cliff, and still in his standing animation spin upside down randomly. So, to explain in long terms what could have taken a sentence, we're going to freeze his Z rotation. Z rotation being, if we go back to the transform, this. We don't want him to be doing this. If we're going to make him do that, he will do that via us telling him to, and not randomly when he falls off of objects, feels a force hitting him, etc. So set that back to 0. So no rotation on the Z axis. Do not freeze his X and Y position. Do not do that, or otherwise your character won't jump and he won't move left and right. Alright, so we're going to close rigid body 2D. We're going to pause for a moment, because I realized something in between episodes here, and that's why this has taken such a long time, because I had to find a way of fixing it. The hero, if we go to hero and opponents, we're going to go to our idle animation. We're going to click on one of these. Minimize this, but go into your sprite editor. Now, this looks normal. This is our character. Nice to meet you. I don't know. Should we call him Jim Bob? I don't know. Something like that. Mr. Jim Bob here has a bit of an issue. I'm going to close the sprite editor because I probably should have shown you the issue before anything. Right, we need to zoom in on Jim Bob. You can move around this scene by clicking the hand and moving around. That only works in the scene view, I've realized. Alright, anyway, zoom in on Jim Bob. One thing we need to kind of change is he's got this horrible issue where he's not central in his sprite sheet. Now you're probably going, Josh, I'm like 4. Please explain this in better terms. Well, when we spin him, he does this. When we spin him, he does this. Nope. This. That's probably difficult to understand. Anyway, the point is, if I leave my mouse here, I need to select this, and then go -1, you'll see that he appears on the other side of the mouse. That's the best way of showing you what's happening. He's not central. So this is something you need to do with all of the art. You need to change so that he is centered. Now the easiest way to do this is to, as I was going to do before, go into the sprite editor, and you see this little blue dot here. You see how it is not at like his belly button, which would be the center of him. It's over here on his right. That means that if you flip the sprite, he is going to appear over here, which is bad. We don't want him to be able to glitch through walls or something like that. That would really make our game suck. So, what are we going to do? We're going to go down to our pivot because he pivots along the x-axis. We're going to change this to custom, and we can click and drag this pivot point, and you'll see that kind of around here is his navel. It's like between like the robe that covers his crotch and the chest plate that he's wearing. So I reckon that's a good point. This is roughly 0.36, and this is roughly 0.5. It's slightly off, but it doesn't matter. So that's a pretty good central. If you want it a little bit higher, I guess you could do that, but those are just easy numbers to work with, and we won't really have to change them. We can just apply them. So change that. So custom, change that, and click apply. And you'll see that now when we select our player, because he's using the sprite we just changed, the idle one, we can tell because sprite renderer idle one is selected. So if we go here and we put our mouse back up to here, and we change that back to 1, we can see that his arm moves, but he actually does change direction. So we're going to leave him at 1, his X scale, and then we're going to select every single sprite in this entire package, and we're going to change this for all of them. Now, don't ask me why the artist did this. It's really frustrating, but this is just something we have to change. So select the first one, select the last one. You can do this from the inspector. So you can open pivot, you can click here, go to custom, and we're going to set this to 0.36. Now you can check as you go to make sure that this is all in the right spot, and I would highly recommend that. You don't want him to be spinning around a weird axis, flipping along the X in a weird way, because once again, when you make a wall, you kind of want it to be solid. You don't want him to just flip and enter it. That could be really bad. I'm going to do the same thing through pretty much all of here. Jumping animations might be slightly different. We'll check them together. So if we go to the sprite editor, we go to custom, and we go 0.36, you notice that's still like in the center of him on the X. It's not in the Y. You could move it up a little bit, but I'm not going to. I don't feel that that's really necessary right now. If it becomes necessary, we'll make a video where I tell you how to change it. But yeah, 0.36 is the number I decided on when I was working on this. So we're going to click apply. We're going to close that. And then you can press Control A to select everything inside the folder. Then go to Pivot, Custom, 0.36. And do the rest by yourself. I'm not going to do them right now. I'll do them in another video. Okay, so let's get into the coding portion of this video. Sorry about that. One last thing, we're going to add two components really quickly. We're going to add a box collider 2D, which we'll edit in a second, and then we're going to add a circle collider 2D. Although a circle is only a 2D shape, so I don't know why it needs to be called that. Anyway, we want to edit these really quickly. We're going to use the circle so that he can travel uphill. I had a better demo in my second version of this, so I need to build that in a minute so I can show you what I'm actually doing. But to begin with, where's the button? Alright, you see this button here? It's got like three squares connected by lines. We're going to click that on the box collider. And then there should be a slight color change between the colliders. Anyway, there's little squares that appear, so you can drag these down, and you can move them so that they are kind of the width and height of his body. I like to drag it just inside a little bit. Make sure that they kind of sit inside one another, just a little bit. You don't want there to be a gap here that, say, a bullet or a throwing knife could travel through and potentially not damage him. Unless you want, like, a cool feature where if something goes in between his legs. Or where something can go in between his legs. I don't know. You do you. But this is how our character is kind of going to look. One thing to keep in mind is if you invert the X scale, you want to make sure that it kind of looks the same on his -1, his flipped side, right? So you'll see that it still fits within his entire body. Roughly the same. And that's good. And we are going to save. Save frequently. Save yourself a lot of frustration. Okay, coding. Take 2. We're going to add the script we created just before to him. So we're going to go to Metroidvania. And we're going to click here. We're going to go to player movement. Now there's nothing in player movement right now, so obviously when we press play, nothing is going to happen. Right, he's just going to stand there. Nothing works. And that's fine. We don't care. What we are going to do is we're going to jump over to Visual Studio. We've got the start function here, and we've got the update function. I don't need the comments because I know what these are going to do. I'm going to add comments that'll help you with other things. So, 2 things that our character absolutely must have for this script to work is, and we're going to make sure that he has them by using some lines of code here. We're going to make sure he has, so we go require component type of, and we want an animator, because we're going to control his animations. So animator must be there, right? Or otherwise we can't animate him inside of this. Then we're going to kind of copy this again. Require component type of. The autocomplete isn't working very nicely for me. And we are going to require a rigid body 2D. Cool. So this is going to control the physics. This is going to control the animations. We must have them. Then we need to declare the fact that we actually do have them. So we need, and we're going to keep these private. Private, protected, and public are 3 different things you can set your variables to. So a variable is obviously something that you want to change, modify, play with, etc. to perform a task. So it can be as simple as it being an integer number, as in a number that doesn't have a decimal place, or a float or double, which is a number that can have a decimal place and a very, very long one too. Then you can have your different types of game objects inside of Unity. So you can have a circle collider, you can have a rigid body or an animator, and you can access these. So we need to do that right now. We want to keep them private because when we create our script, we don't need to modify these in any way inside the script, and we also don't want to be dragging these onto the script to tell it to do something with these objects. We just want to leave them alone, kind of ignore them, etc. So we're going to call these as private. And we're going to go a rigid body 2D, and we're going to call this RB2D. Then we're going to create another one called private animator, and we're going to call it my animator. And we're going to leave that there. So we're going to comment these and say that these are necessary for animations and physics. Then we're going to need to work some things out, like we need to know what our player is going to do inside this script. We know he's going to move, but we need to work out kind of how fast. So we're actually going to create a float to control how fast he moves. So we're going to go public, because we want to be able to edit this one, float speed, and we're going to make this equal to 2.0f. The f just means that it is a floating point number, or a number that is, so it is precisely 2 right now. It's not 1.9999998, or, you know, add a bunch more 9s before the 8. It's not anything like that. It is exactly perfectly 2. And that is slightly important to tell the computer to work out. Anyway, we're going to call this our variables to play with. Another one that we are going to create, but we're not actually going to set, is a public float to keep track of our horizontal movement. And so yeah, we're not going to declare this, we're not going to set it as something else. And that's because it will be set by a function that we're going to call, right? So we have our start function here. I'm just going to make sure that these are private, just because I don't need to, but it's a good habit to make sure that your functions are private, unless you want them to be public. So if you're going to create a damage function, other characters in your game might actually need to use that, so you'll need to make it public so they can use it. But we don't want anyone touching our start function or our update function. Those are purely for our character, and nothing else can touch it. Right, the first thing we're going to do is we're going to make sure that our character actually finds its animator and rigid body, or otherwise we can't use them later on for the rest of our code. Right, RB2D is equal to, we're just going to tell it to get the component off the player, and we're going to look for a component of type rigid body 2D. And you put that there, and then semicolon. See, everything ends with a semicolon. And then we're going to go my animator is equal to, and do the exact same thing. Get component, animator, and cool. So now that we can actually use these variables, we're going to set about doing that. So we're just going to make sure we know that define the game objects on the player. Define the game objects found on the player. Just so that makes sense. So we're going to be using two functions to handle physics. One of them is going to be update. Update will handle the input for the physics, and then the other one will be running the actual processing of the physics. We don't want the physics to run in time with the frames, or otherwise there will be some... What I spent way too long trying to say here is that your frame rate is the rate that update runs at. So that's the FPS of your monitor. Now, if for any reason that stops, your physics that are run by update will stop just entirely. So what you actually want to do is you want to run it in time with the internal CPU, where if that stops, your entire computer is crashing. So it's the difference between the consistency of the two. One can stop and it's fine. The other one, if it stops, it's a massive issue that, you know, your computer's crashed. But that's no longer a game issue, that's hardware. This function is going to run all of our physics, and this function is, and we're going to write this, handles input for the physics, handles running. Right, what we're going to want to do inside here is we're going to want to move the player. And here we're going to want to check if the player... yeah. Let me change this to character, just so it makes a little bit more sense. Alright, so check if the player has input movement, right? So if you press WASD, we want this to check it. Then this is going to move the character left and right. So we're going to, up here, we're going to check which direction the player is moving. So check direction given by player is probably a better comment to put in. Cool. So now that we kind of know what we're doing, in here, we're going to make this based on input, right? So we're going to give our horizontal movement and set that equal to our input. What input are we going to use? We're going to use... So what I once again took forever to explain is that Unity has horizontal and vertical axes that are built into the software that it recognizes as a thing. Now, these are input into the program as a floating point number, and that can be used to determine which direction something is moving along those axes. So obviously, if it's heading negatively, it'll be going towards the left. Positively, it'll be moving towards the right. I don't know why it took me that long to explain. Anyway, there's buttons associated with increase and decreasing that. So, yeah, that's pretty much what I took, what, 10 minutes to explain? Well done. The button axis, so... long-winded explanation over. Jump back in here and go input.get axis. And we're going to go that, and horizontal. Make sure you spell it correctly. If you don't spell it correctly, it won't know the axis that you're talking about. So, that's all we actually need to do in there. Now we need to tell it how to move the character based on our horizontal movement. Right now, we want to go rigid body 2D dot set velocity. No, just dot velocity is going to be equal to. So we have that the speed that we set before, and we've now got our horizontal movement. So this is going to be equal to 1, -1, 0. let's just go a big or. Whoops. Or 0. Okay? So 1, -1, or 0. So we know that that's going to be equal to something. So we'll be going 2 multiplied by either 1, -1, or 0. Get axis is... So there are two ways you can do this, and I suppose I should address this as well. You can either do get axis or get axis raw. Whoops. So get axis raw means that it will only have 1, -1, or 0. And that's fine. It means you turn around instantaneously. If you have just get axis, it means it's slightly smooth. So it'll slowly change between the number 1 to 0. So it'll have a bunch of decimal places in between based on the fixed update. So it'll change it very, very slowly. You won't turn around instantaneously. You'll turn around very quickly, though. So it's not going to be like a noticeable difference. But you can test this if you want. And actually, we should probably do that. So we'll set it to get axis to begin with. And I'll show you that. And then we'll change it later. So rigid body 2D dot velocity is going to be equal to... Now, velocity is a vector, right? It has direction and magnitude. So we need to create a vector out of our velocity and our speed and our movement, because we have a direction based on the movement and we have a speed. So we actually have all the components that we need. The one thing that I will say is that velocity, when we're doing it in a two-dimensional plane, it also needs to take the y dimension into effect as well. It needs to think about that. What we end up doing is we go new vector 2, and we're going to open that, no quotation marks, and we're going to give it our horizontal movement, so that's our direction, multiply it by our magnitude, our speed, which we can change later, and then we are just going to tell it to pretty well ignore our y velocity, just give the y velocity whatever it wants. If that makes sense. So we don't want to set our y velocity to 0, or otherwise if we try and jump and move at the same time, the game will break. We don't want to set it to, say, -1, or otherwise we'll start moving down every time we push right. So we just want to go take into consideration what the y velocity is, but don't touch it. So we're going to go rb2d dot velocity dot y. And so this just gives it... it accesses it, it'll look at it and go, okay, I don't need to change you, but I now satisfy the conditions for having a vector. Because a vector is, a vector 2 is two-dimensional vector. So you've got your y and you've got your x, and we're only changing x. Right, and our character should actually move now. It's pretty quick, wasn't it? So we're not going to focus on flipping today. We'll do that in the next video, because this has already been 37 minutes of recording. So we're going to press play. You might want to maximize on play for this. I'm going to press play. And if you press D, I'm noticing he's going behind the pillars. That's fine. But my character moves. Now, that test we were going to do. We're going to stop this. So what was I going to change? Over here, raw. Cool. So if I go back to here, this will load the script. You'll see a little loading bar down in the bottom right. And then if I press play, focusing on horizontal movement again, we can still move, but you'll notice the movement is much quicker. And so that might be what you want. As I said, it's not too noticeable a difference, but there is definitely a difference in the way that you are moving. So you work out whichever one you want to use. I actually like get axis raw. Now that I've tested it, I actually like this better. So we're going to go with that. But once again, the code doesn't change too much. It's just one, it's changing the keyword here. But that's your player moving. So once again, thank you for watching. Okay, thank you. Bye-bye.